Hello, this is Tyler Beamer, math instructor at Haywood Community College. This is an instructional math video for DMA 040 in regards to Section 9, percent problem solving. So here are some key words to know whenever we're going to solve percent problems. What means variable? So that's your variable x. Basically that's unknown. Of means multiply, and is means equals. So those are three key words to know that'll help you translate these word problems into equations. So here's an example. What is 9% of 65? So the what is the x, is equals 9%. We want to make that into a decimal. So remember how to do that. 9%, move the decimal 2 places to the left to make the percent into a decimal. Of means multiply, and then 65. So that's going to set up an equation that you would want to then solve for. This one's pretty easy to solve because x is already isolated. We just need to multiply 0.09 times 65. So 585 would be 9% of the number 65. So all of these problems are different variations of this same type of problem. If you know those key words, that'll be helpful for you to solve. Alright, so here's another variation. 36 is, so is means equals, 6%, make that into a decimal, 0.06, of times what means x. So then that's going to set up a equation for you to solve. 36 equals 0.06x. So then we divide both sides by 0.06, and that's going to allow us to solve for x. So 36 divided by 0.06 gives us 600. So 36 is 6% of 600. Okay. Here's another variation. 24 is means equals. What percent, that's x, of, once again, means times 144. So we get 24 equals 144x. So we solve the equation. Divide both sides by 144. So x equals 0.16. And so this is the percent as a decimal. So then the last step is to then make the decimal into a percentage. So move the decimal to the right 2 places, and that gives us 16%. So don't forget that last step when you're finding the percent. So those are the three different types of variations for these problems that you'll see. Once again, if you know those three key words, you just set up the equation, and then the equation for these are pretty simple one-step equations to solve. Okay. You'll also see some problems where you are using percents to solve. A lot of these are centered around retail. So here's an example. Mark's taking Peggy out to dinner. He's got $66 to spend. If he wants to tip the server 20%, how much can he afford to spend on the meal? So keep in mind that the total cost is equal to the cost of the meal plus the tip. So he's got $66 to spend, so that's the total cost. We're trying to figure out how much he can spend on the meal, that's x, plus the tip, which is 20% of the cost of the meal. So 20% as a decimal is 0.20. Now I can't leave it like this. If I just leave 0.20, then I'm literally just giving a 20-cent tip. So I have to include 20% of the cost of the meal. So that needs to be 0.20x. So then there's a 1 there. These are like terms. So I get 1.20, and then I can divide both sides by 1.20. to get 55. So then he can afford to spend $55 on the meal, still tip 20%, and be within budget. All right. Another type of retail problem. Julie bought a leather sofa that was on sale for 35% off the original price. What was the discount? How much did Julie pay? So the discount is 35% of $1,200. So that's 0.35 times 1,200. So then the discount is $420. So then to determine how much she paid, right, the discount price is going to be the original price, $1,200, minus the $420 discount. So we get $780 for the discounted price of the sofa. Okay. Percent increase. So you see this statistic quite a bit in the news. You take the amount of increase over the original and then make that into a percent. So here's an example. Cost of a certain car increased from $16,000 last year to $17,280 this year. So then the amount of increase can be found by subtracting those two, which is $1,280. Okay. So then to find the percent increase, I take that amount of increase and divide it by the original. So the original is going to be the smaller of these two numbers since there was an increase. So that's going to be the 16,000. So when I divide those two, I get 0.08, and so that is the percentage as a decimal. Once again, to make it into a percentage, I just move the decimal to the right two places, and I get 8%. So there was an 8% increase in the price. Okay. Percent decrease is a similar situation, except instead of an increase, there's a decrease. So Patrick weighed 285. He began dieting. He now weighs 171. What was the percent decrease? So once again, find the decrease by subtracting. So 285 minus 171. So he lost 114 pounds. So then the percent decrease is going to be the amount that he lost over, once again, the original. And if this is a decrease, it's going to be the larger of those two numbers, right, since it was a decrease. So the larger of those two numbers. So 114 divided by 285, which is 0.40. And then that is the percentage as a decimal. So then move it to the right two places to make that a percent. So 40% decrease in his weight. Okay, so hopefully this helps you in these particular problems with percent problems. As always, if you have any questions, please feel free to email those to me or stop by the office. All right, thanks. Have a great day.